So in this one, we've got to do a little bit of implicit differentiation because the y is not already solved for. It's not by itself here. It's stuck in here. You could, if you preferred, try to solve for y. It's not impossible in this one. You can just raise both sides, or make e the base on both sides. That'll cancel out, and then you can bring the 2x over. So you can do that. Or you can just leave it as is and do implicit differentiation. That is what I'm going to do. Derivative of natural log is 1 over whatever is inside the natural log, so that's 2x plus y. And then it's chain rule, so I have to take the derivative of that inside, which is going to be 2 plus dy dx. And then the derivative of the right-hand side is just 1. And now I need to solve for dy dx, of course. Easiest way to do that is going to be able to take this fraction here and just multiply it to the other side and then subtract the 2. If you do that, I think without too much trouble, you can see that you'll get a 2x plus y and then a minus 2, which is this answer here. Okay. This one is sneaky. It's asking us about position and velocity, and so we know that velocity is the derivative of the position. And they're asking us, okay, what is the position if we're given the velocity function, and we're also given the position, at time t equals pi over 2. And what they want to know is what is the particle's position at time t equals 0. And so the way I like to think about this is we would have your start plus displacement equals finish. Because that's what displacement is. Displacement is how far did you go from your starting position to your finishing or your final position. So we're given the final position. At time pi equals 2, the position is x equals 4. We need to know what is the initial position. So I just need to put the pieces in here. I need to figure out this and this. I'm given this. So of course, to find the displacement, you just take the antiderivative, the definite integral of the velocity. So my displacement is going to equal the integral from 0 to pi over 2 of v of t dt. And so I have to take the antiderivative and plug in. And if I look at that function v of t, I got to think, okay, that's the derivative of position. So what could the position function have been? Well, certainly it had to be a negative cosine. Because this is the derivative of some other function. Well, what is sine the derivative of? Sine is the derivative of negative cosine because negative sine is the derivative of cosine. And then I've got this 2 here, which tells me there had to be some chain rule here. The 2 would stay inside, but then there needed to be something out front because I should have multiplied here when I take the derivative. If I took the derivative of this, there would be a 2 outside from chain rule. But there isn't. There's no 2 there. So that means I must have started with something out here and then it canceled out. Well, what's going to cancel out when I multiply it by a 2? A 1/2. So I'm going to have 1/2. And if you just think about it, okay, well, what if I started here and I took the derivative? Would I get this? Yes, I would. And then it's displacement, so I need a definite integral, so I'm going from 0 to pi over 2. So I plug in pi over 2 and I plug in 0 to this. I'm going to get negative 1/2 cosine. Well, because there's the 2 in there and I'm plugging in a pi over 2, that's just going to be pi minus, well, now it's minus negative 1/2, so it's plus 1/2 cosine of 0. Cosine of pi is -1, so this is going to be then a positive 1/2. Cosine of 0 is 1, so that's again a positive 1/2. So this is 1. My displacement is 1. So the question is, what was my initial position? What was the position at time t equals 0? Well, if my displacement was 1 and I finished at 4, at pi over 2, we were at 4. Well, where did I have to start? Well, I had to start at 3. All right. Definitely a sneaky one there. You have to think through that a little bit and think about, okay, what are all the things I know about position, velocity, and how those things connect to each other here. All right. A little more straightforward here, equation of the tangent line. We do have to, again, do quotient rule, but that's tedious but not hard, hopefully. So y prime is going to equal low d high minus high d low. Square the bottom, and away we go. And we're doing this at the point 1 comma 5, so I need to know what the derivative is when x equals 5. If you when x equals 1, when y equals 5. If you plug in 1 to all of that, you're going to get 13. And then they're giving us the equation in more or less standard form, which nobody likes standard form. So I'm going to start with point slope form because that's what I'm familiar with, and then I'm just going to turn it into what they want. So y minus 5 is equal to 13 x minus 1. If I rearrange that, I'm going to get sorry, actually I missed a negative here. There would be a negative 13. So then we're going to get y equals negative 13x plus 13 plus 5. And then I just need to look at, okay, well, which one of these is going to work? And that should be the first one. If I move the 13x to the other side, it will be positive. The y stays positive. Leave the 13 plus 5, which is 18, on the right. There we go.